Hello friends, I am Naren, your host, and I am back with another video. In this video, we're gonna talk about a very important feature of Terraform, its module. So let's talk about Terraform modules. What is Terraform modules? Modules are a way to organize and reuse your code, making your infrastructure as code cleaner and more maintainable and easier to scale. You can think about functioning programming language. Modules are more like a function in programming language as if you are familiar with any programming language like in Python, we create a function and we pass an input to a function and run a definition of the function, and the function will return the value. So module is doing the same thing in the Terraform. You create a module, definitely module have some input are nothing but like a module parameters. You provide those parameters or value of the parameters, then we launch the infrastructure. After infrastructure launched on AWS, we return output of the infrastructures. So that is the module, and modules is simply a folder with .tf files that define your resources, variables, and output. In this case, variables are the parameters of the modules and outputs are the output of the execution of your module. Now basically there is two types of module, you can say. Like, it's not exactly the type, but we can say like one is the root module, another is a child module. Root module is mainly working directory where you run Terraform init, Terraform plan, and Terraform apply. Child module, a module called from another module. So in this video, at the end of the video, I will going to show you the demo. In this demo, we will have a root module, we will have a child module. So we will discuss both the things in the demo session. So let's move next slide. Now, why you use module? That's a very good question, because like we know sorry, we have the modules and it will help us to uh, doing some great work. But why this module exists, why we used to use this module in Terraform? When you define module, now we are defining this module for the reusability, meaning you are, let's say for example, sorry, let's say for example you are creating a VPC. When you are creating a VPC, so this VPC can be reused for further script or further module. For example, after creating the VPC, you may want to create an instance. So when you are create the instance, of course instance should be go inside one VPC, right? So instead of creating a new VPC every time when you are creating an instance, why not use the VPC module? So reusability of the module provide the reusability, so you can reuse your existing code for better usability, or you can write the faster code. Now organization, modules are the way to organize your code. You can split your code module by module, and you can design or organize your code in much more cleaner way. Maintainability of module is really a very good feature that module have. When you are writing a module, or when you are using a different many modules, maintain of this module is much easier. Or maintain your, like, if there is a problem in VPC, then you can only change the VPC module regardless of disturbing your EC2 modules. And consistency. Once you define a module, it will be accurate, consistent, it always be perform the same task without any error until and unless some environment problem. Otherwise, modules are working fine with the consistency. So this is why we are supposed to using the module. Now, what is the basic structure of the modules? Like many people ask, like they still confusing. Many new beginners are still confusing when they are writing the modules. Now, here I am listing the basic structure of the module. In this way, you can write the module. When you are writing a module, you're supposed to have a main.tf file. Main.tf file contain your resources. It contain including backend definition, including all your VPC configuration. All the things are stored in the main.tf file. Then you have a variable.tf file. Variable.tf files, you can understand it's an input variables for your module. Let's say when you are creating a VPC, you might have a VPC name, you might have a VPC size CIDR range. So all these input variables you can define in the variable.tf file. And output.tf. Output.tf is more like a output values. Like when you once you create the VPC, you maybe need a VPC ID. So VPC ID you can display in the output.tf, or maybe you need a subnet IP. When you are creating a VPC, you also planning for a private subnet and public subnet, and so there may be a possibility that you want to so the ID of your VPC, ID of your public subnet, ID of your private subnet. So in the output.tf file, you can, give the output values which are really required to access in order to get the output of your modules. And the readme file is nothing but you can describe your module, and it's a way to show like what is the module purpose and how to use it, how to run, how to use, what are the parameters, what are the input variables that this module support. Now, calling a modules. Now this is how to call a module. This is very a good question, that once you define a module, definitely that module will going to use by some other script. So you have to call this script. Let's say you create a VPC module. After creating a VPC module, you are creating a VPC test script. In this VPC test script, you are going to call the VPC module in order to make sure that your module is working fine, right? So when you are calling a module, Terraform have the keyword called module, and then you can give your module name. In the property, you have to specify source of the modules. Later in the slide, we will discuss how many way the source, what are the value for the source property. So right now we are specifying local path to the source property, and then you can provide the input variables for your modules, like as I said, like CIDR block and region, or maybe VPC name, or maybe subnet name, subnet CIDR block, many more. Now, module source. As we discussed in the previous slide, there are multiple source you can get the modules. So Terraform support different source options. Of course, we have seen local path. You can also use your Git repository path, but you have to specify your GitHub repo name in order to access the Git repository. This repository is nothing but like you are creating a modules repository, and it's a great recommendation that one module create one repo, so it will be very easy for you to track, or include or maybe call the source Terraform modules from the Git repository. Now, a third way is the Terraform registry. Now, Terraform also support or also provide a feature that you can publish your module on the Terraform registry. About the Terraform registry, how to publish the module on the Terraform registry, we will discuss maybe on upcoming videos. But if you just assume that you have your private module or public module deploy on the Terraform registry, then you can use this. You can call the module like source Terraform AWS module VPC AWS. Okay, this is the way you can calling the module from the Terraform registry. Now this is the public module, the URL, as you say, this is the public module, but you can create your private module as well in the Terraform registry. What are the best practices when you are working on the Terraform modules? See, first thing first, whether you are working on modules or writing a function in any programming language, make sure your function or your modules are small and focused on specific things, right? That is the basic way of the function, that is the basic recommendation for function or the Terraform modules. Like for example, if you are creating the VPC module, make sure you have focus on VPC, all the resources related to VPC. If you have EC2 modules, then make sure that you are focused on compute services and so on. Use versioning. See, whenever you are defining a module base, always use the versioning when pulling from the registry or Git. Now, as I said, like when you create a module, let's say you create a module and publish to the Git on the GitHub. Now, first time when you create a module, there is possibility that you are support less parameter. Later, when the QA team or some other team are going to use your module, then they found that this module may have lack of a parameter, right? Lack of parameter that are missing. So in that case, you have to jump again and provide more parameter as as the user suggested. Then you have to create the versioning, so it will be easy to track what are the changes you have done, and existing users might not be conflict when they are using the latest version. Documentation, input and output in the readme. This is really a best practice when you are writing any modules. You have to give a clear, see, if you are writing a module for your personal purpose or like just for your use case, it's okay to not write the document. But when you are working in a team, right? So and other teams may use your modules, the module you created that is going to be used by other team. You have to provide the clear documentation about the input and output in the readme file, and avoid hard coding valued inside the module. Sometime we all make a mistake just because easy to do, right? So we are just putting the hard code value in the module. We have to avoid that kind of behavior. When again, when you are writing a module for a team, you should not be put anything hard code. So everything you are doing in the module should be defined in the variable.tf file, right? This way you can easily maintain another other people make your module very useful. And when you are writing a modules, provide a default value. Even the user is not specify the input value. Make sure your module is self capable to launch the resources. Okay, so that's all about the Terraform modules. Now let's take a demo. Let's look at the demo. And in the demo, we are going to create two module, VPC module, and we also deploying a static website on S3 bucket using the module. So let's see the demo. And to see the demo, we have to move our command prompt. And here is my command prompt. We have the root folder. In this root folder, I create a Terraform module folder, and inside this folder I create a backend.tf, create s3 bucket.sh, generate backend.sh, module and module test. Here there are two important things, module and module test. Okay, so let's open this project in Visual Studio Code. Now I am in Visual Studio Code. So this backend, I created the backend here, just want to make sure that when we are writing a multiple modules, so each modules, like in the s3 bucket, this is my bucket that I already created. You can also create, if you can also create your s3 bucket by using create s3 bucket script. This script is nothing but it help you to create the s3 bucket, whatever the bucket name you specified, and the region name. Okay, so I create the bucket name here, and I want my Terraform state file in such a way that when we have multiple module, for example, if I'm going to S3 static website, then it's saying like Terraform module test, and then folder name, static website test, and then keep the state file. So according to my backend, is the key should looks like when you are running, when you are executing a static website test, the key looks like, let's say module test, and then I'm saying static website test, and then slice state. Okay, and if you are executing VPC test module, then the key will become VPC test. Okay, that's why I create the backend outside. So when, if you want to destroy static website, then VPC test will not destroy it, keep as it is. That's why I wanted to have a backend outside, and manage in such a way that all the module, since we have defined the module and we are testing the module, so when your testing is done, you can destroy the testing part as well, right? So one by one. So let's get started. First, let's see the modules. Like we are going to see the VPC module here. Let's not save the file, and we enter in the VPC folder. Here you can see main.tf, output.tf, and provider is nothing but I'm just putting here, but it's not really required. But if you want to keep, you can keep it, because sometime you do not want to create a test module, but you can directly test your model, then you have need this. Okay, so in the main.tf file, you can see I have created a VPC resource, and I'm getting the cider block from the variables, and that variable files is here. So this is my cider block for the VPC. Then I create a public subnet. In the public subnet, I have multiple public subnet. You can see in the variables that this is the public cider, and so this is my public cider default value. So I am getting the public cider because cider is this variable is a list variable, right? It contains one or multiple cider blocks, so that's why I'm counting and initialize the count variable, and then for cider block I am giving the index. Okay, so this is how we can create a AWS public subnet. And availability zone, again it is in list variables, and you can see in the variable file that we have AZs we have 3 AZs, right? So this way it will get all the 3 AZs and defining here availability zone. Okay, and then at last we have a tag name for the public, that we are getting VPC name, we give the public, and then we will say count index plus 1, so something like that. sorry. And we also create private subnet, public and private in the similar way, so you can copy paste. Then VPC, when we are creating a VPC, we have to create the internet gateway to access the internet in the public subnet. All the resource you deployed in the public subnet, you have to get the internet gateway. And then we have a public route table, and we also associated our internet gateway into the public route table, and then we have associated our public subnet to the route table in order to access the internet. So this is all about the VPC modules, and here are the variables. And I will also publish this project into Git repository, and then you can refer my Git repository from the GitHub. I will also share the link of my GitHub repository in the YouTube description, in my YouTube video description, so you can also refer the GitHub URL from there. So now, and this is the module code. I create one VPC module. Now let's test this VPC module whether it's working or not. When I'm testing this module, you can see I have a main.tf. So in the main.tf, I'm mentioning that you can get the modules from here, and the folder name is VPC. So VPC is here, and I'm providing the variables from here, and also creating the AZs, two AZs. Okay, so let's directly jump, and in the output we have VPC ID, subnet ID, and subnet private subnet ID. So let's go to the console, which says cd module test, and we can go VPC test and run the Terraform init command. Now it will be initialize the backend, and then once initialized the backend initialization is successfully, Terraform plan, we execute our Terraform plan. So in the Terraform plan, it will be list out all the resources that are going to be created. Now Terraform plan is get successfully executed, and we have 9 resources to add. Let's add them. Terraform apply, and enable the auto approve flag, so it will not ask user confirmation to ensure that you are going to apply the changes. So now VPC is going to create it. VPC is creating, Terraform is creating a VPC. Once it's done, then you can see these are the output. We have created 2 private subnet and 2 public subnet, and here is the VPC ID. So now let's go to our AWS console. In AWS console, we can enter VPC. Let's open in a new tab, because this existing tab we also need it. Okay, now you can see we are in the east default region, that is North Virginia. Now if you go inside this VPC, then you can see my custom VPC is this, and then if you go inside the VPC, you will have route tables, and on the subnet you will also give my custom VPC public 2, private 1, and public 1. These are the subnet that we have created. Now let's move to the interesting part that I wanted you to understand. We have a module test folder appeared here, because if you look at the main.tf, or if you look at the backend, because we initialize the backend here, so we specify the paths here: module test, and the VPC test, and the Terraform state. Okay, so in the VPC test module, we have created the backend, and we wanted to store the backend in dedicated folder that is called VPC test. So here on that you can see we have a module test and we have a VPC test, and then we have a Terraform state file that you can open by clicking this. So you can see all the details of the resources are exist on the state file. Now let's do one thing. We can go here and then we can now let's try to deploy an S3 static website. Before we are running Terraform command, let's take a look about our S3 modules, our S3 static website modules. So we have S3 static website modules. Same, we have created the same structure. In the main, we are creating a bucket. Okay, we of course when you are deploying a website on the S3 bucket, you have to create a bucket. So we are creating the bucket. After creating a bucket, we are give the bucket the access, probably a public access, and we also allow the bucket policies, which means that we are giving a public read policy. That means we everyone can read this bucket. And then we have a bucket website configuration. In the website configuration, we are putting index document, that is our index.html, and arrow document, that is our arrow.html. Okay, so this is how we can create a static website in the module. And the output folder is nothing but it give you the website endpoint and the website ID. And in the variables you can specify. Here I'm not give the bucket name, but you can give the default bucket name if you want. But bucket name I will give from the static website test code. Now here we have the arrow document. If you are not specified, this is the file name, we will going to the arrow document. And index document, this is the index.html file we are going to give the, okay. Now this is our S3 website module. Okay, now we are going to test our static website module. So I created the static website test folder. Here I create the build folder. Build folder is required because builds folder contain our website, meaning we have index.html and arrow.html. Apart from that, I create the backend file. In the backend, you can see I create the folder inside the module test, static website test, Terraform test, right? And then we have a main.tf file. This is doing nothing, calling S3 static website module. So we are calling this module, give the bucket name here, and providing these two documents. Now we have provided these two documents, but still we did not upload these two files into our bucket. So we have to upload a file into the bucket. So for that I have defined a resource AWS3 object. This object, this function will help us to upload the index.html file. Of course we are reading from the source. You can see this is the source from the builds folder. I'm reading this file. After reading, I'm saying file md, I'm using file md to upload, and this will upload the file. Similar way we are uploading the arrow.html file. So this is all an output. We are just giving the website URL and the bucket name in order to understand which bucket is created and which website URL is there. So now let's go to the console and we will going to deploy a static website using our S3 static website module. So let's go to the console. Now here we have to go S3 website test Terraform init. We initializing the backend. Right, backend has been initialized successfully. Now Terraform plan. We suppose not to run Terraform plan is not really required to run here until and unless you are just double confirming that everything is working fine or not. You can see 7 resource we are planning. So let's say Terraform apply, and then we give the flag auto approve. This will help us to create all the resource on AWS without asking user confirmation. So now we are creating a random ID suffix, and then after creating the random ID suffix, we are creating a website and uploading the to our index.html file to our newly created bucket, and the arrow.html file to our newly created bucket. After you completed, you can see we have the website URL. So now let's try to access the website in order to check whether the module working fine or not. So if you get hello world, then that means the bucket has been deployed, the website has been deployed in the S3 bucket. And now let's check, this is our index page. We will check the error when you are accessing some not exist URL, then it will be give error, oops, route does not exist. So now that is for this video, and let's double check here in our S3 bucket that the state files that created by Terraforms. So you can see we have 2 state folders here, and in these 2 folders, one is creating a static website state file, and another one is containing VPC state files. Okay, so you can see here that we have the tf state file exist in this folder. Now let's delete one resource and then check whether it will be deleting only that particular resource from the S3 bucket that we used to store the state file of the Terraform. So now let's run the command again, but this time we use the destroy. Destroy will destroy the bucket that has been used to deploy a static website. It will take a few minutes. Before deleting, we want to make sure that we will on the refresh stage. Once the refresh is done, we will destroy the bucket. Now let's say access the website to see whether the website, so you cannot, this URL 404 not found, meaning whatever website you deployed has been removed successfully. And if you go here and you can refresh, the folder exists, but the content of the tf state file was empty. So you can see now there is no content here. That means you have deleted the tf files, and all you have deleted all the resources related to that tf state. Now let's go to the VPC test. VPC test tf state is still containing our VPC information, since because we did not remove it. So next let's go to the VPC folder. We are here in the VPC folder, and we will run the destroy command again, and this time we are planning to destroy the VPC that has been created by us. So it will take a few moments. And before destroying, remember, when you are running a destroy command, before destroying, Terraform always refreshing the local state from the actual state, and then after it get refreshed, and then it will be start destroying. So now 9 resource has been destroyed. Now if you refresh here, then this file become empty. So now you can see this file is empty, right? So we can refresh here. We do not have any resource deployed for the VPC test. Okay, that's all for this video, and if you like my video, Please hit the like button and click on the subscribe button, and don't forget to put your comment, your suggestion in the comment section. Thank you. Thank you for watching this video.